So all this while we have been discussing about normal distribution, standard normal distribution, z distribution, so on and so forth. So we have discussed a lot about normal distribution. But how do you actually determine on whether data follows normal distribution or not? You can determine whether data follows normal distribution or not using normal quantile plot, which is also called as quantile plot, qqplot. It is called as quantile for a reason, because here also you have quantiles and here also you have quantiles. On the y-axis here you have the random variables, that is the GMAT scores, and on the x-axis here you have the corresponding standardized values. For example, if you have 600 as your GMAT score, then the standardized value would be z is equal to x minus mu upon standard deviation. Right? So it is 600 minus mu is 711 upon 29. You'll get a corresponding standardized value. And if you plot in that way, and if the data points fall along the straight line, you can say that your data follows normal distribution. Let me try to explain this using R. The function used to check whether your data follows normal distribution or not is qqnorm. Right? I want a quantile plot to check whether data follows normal distribution or not. And I'll check for GMAT score first. So in order to refer to this variable GMAT, which is there in this data set called MBA, I need to write it in this way, MBA $GMAT. There we go. It appears as if data roughly follows normal distribution. Data points fall along a straight line. But I can also draw that line, QQ line of MBA $GMAT. So you see here that there is also a line drawn there. And this line is from Q1 until Q3, first quartile to third quartile. That is the thumb rule using which this line is drawn. And if your data points fall along that straight line, majority of the data points, you say that your data follows normal distribution. Now let me use the up key to go to the previous function and try to do this for work experience. Does this seem to be following a normal distribution? Absolutely no. I feel that it's a curve there. It does not follow normal distribution. So what do you do if data does not follow normal distribution? You need to transform the data. What do you mean by that? Rather than using work experience as a variable, you're transforming the data to log of work experience. And you want to check whether post-transformation data follows normal distribution or not. If post-transformation data follows normal distribution, you can proceed assuming that data follows normal distribution. There are a lot of analysis that you can do if data follows normal distribution, which will become clear as in how we proceed further. If post-log transformation, if data does not follow normal distribution, what do we do? I'll explain in a moment from now. So let me close this and let me do a log transformation and assign the log values of MBA $work experience to this object called log trans. You can give any name, that's absolutely fine. Object names can be anything. And I'm using an assignment operator here to assign log of MBA $work experience to this object. Now if I do a QQ norm of this object which holds the log transformed values of work experience, You notice that the data follows normal distribution now. Earlier it was like a curve, now it's a straight line. So majority of the data points follow along the straight line, and this goes on to say that your data now follows normal distribution. What if the data still appears like that? Post log transformation. Then you can try out exponential transformation rather than log. If post exponential transformation also, if your data does not follow normal distribution, you can try out reciprocal transformation. If post reciprocal transformation, if still data does not follow normal distribution, you can try out square root transformation. If post square root transformation, if your data does not follow normal distribution, you can try out 1 by square root. So on and so forth. How many transformations are you going to employ? As many as possible. It depends on the time that you have at your disposal. How much time did the customer give you for the analysis, right? More the time you spend, more will be the transformations you might want to apply. But practically we implement 2 or 3 kind of transformations, maybe log transformation, maybe exponential, maybe square root, maybe reciprocal. If data does not follow normal distribution, then we proceed with those techniques which assume data are non-normal. There are a few techniques which deals with non-normal data, and there are a few techniques, or majority of the techniques will deal with normal data. To do more analysis with your data has to follow normal distribution. And this is the reason why we are transforming and checking whether data follows normal distribution or not. All right.